G'day all, Matt Roberts here. We have our solutions to the week 1 tasks. Sorry, week 2 tasks? Yes, week 2 tasks. Anyway, 3, 4 and 5. Now 3 you've already got the solution to. Excuse me. That was discussed in another video. So I'm starting from that solution. I'm going to talk about task 4 and we'll talk about task 5 as well. So task 4 is about object-oriented modeling. So we've asked you we said the grid has no identity, it's just drawn. Later on we need to do lots of things with this grid, we'll modify it and adjust it, so on and so forth. Our task is to refactor the program to give the grid its identity. So refactoring means taking a program that does something already, changing the underlying code but not changing the functionality. So we've been asked to give each the grid a paint method and to create a cell object and probably give it its own paint method. I think that's implicit in the question, but maybe not explicit. So let me explain what we mean, because I think that's the challenge here. What do I mean by giving something an identity? So there's a couple of things in this program that have an identity already. It's the app and the main. And those things are classes, or we've got a class defining those things, which means we can have objects of those things. So you can see here we've got a section on line 27 where we create a new main object. And now we have a main object. It's like it's a bag with fields and it's got access to some methods. We can put it into a variable. We can make that variable reference the main object. And now that's the identity that I'm talking about. That object can be sent around to different places. We can update its state. We can call methods on it. There's a lot we can do with something that's an object. At the moment, the grid that's getting drawn on the screen, it sits here, is a pile of rectangles that I created in this code here, lines 16 to 20. But it's code that executes on that paint method, and then it's done. It's gone. Once the execution's done and the stuff's been drawn on the screen, I don't have it anymore. There is no grid that I can pass around, modify, call methods on. So I want the thing that's happening here to be an object somewhere. Okay. So really what I'm saying, I guess, is that maybe I want my app, or maybe I want something else. Let's go with the app, to have a grid that it can work with, an object, really. Everything that we're giving an identity to in an object-oriented language is an object. So I want to build a grid object. Something like, if I think about what I'd like the program to look like, that guides me to what I should do. I want the application, so the app, to have access to this grid and to be able to keep it around and use it in different places. So it'll build it when it creates itself with a new grid, just a constructor or something. And then instead of down here just doing the job of drawing all those rectangles, it'll say, look, I've got a grid, and grids know how to paint themselves. We're assuming they do. So let's just do that. Okay. Now, when I try and paint the grid, I probably have to send it the graphics to paint on. But this line here, where I've stored the grid, it has an identity, and part of what it knows how to do is paint itself on the screen, is what we're aiming for. So to do that, to be able to build an object of type grid, I'm going to need to make a grid class. So that's what I do. Now this grid class has to kind of represent all of this stuff. When I'm refactoring, I can often just take the code I've got and move it somewhere else. And I could do that here, but I want to think from scratch about what the grid class should look like. So always classes are, start with the name of the class and off we go. Then classes always have some fields, and they always have some constructors, and they always have some methods. So in this case, what makes sense for a grid to be made up of? Because the fields of an object are what it's made up of. The application here is keeping track of a grid because the application is made up of a grid. That's all that's on the screen. But what does a grid keep track of? What's it made up of? Well, in this case, the question should have pointed us in the direction of the grid being made up of cells, many of these cells. So in fact, I really want here a grid to have some fields to represent cells. All right, well now what are these cells going to look like? How am I going to store them? That's our question. I'll start with just the basic grid though. So no fields for now. We put in the constructor. I don't need the new there, sorry. Public grid. So that's the default constructor. So, and the method that I want this thing to have, the thing that it's able to do, is to draw itself. And if we're going to draw something, anything, we're definitely going to have to give it something to draw on, which is like the graphics object. So I've got to import that. Let's see if it can automatically bring it in. It can. So the code that I was doing before to draw a grid should really be in here. This paint here. I'm just taking this code and moving it over there, really, which is quite often what happens in refactoring. And we've got to import these things again. So I can just import AWT star to get everything I need. And this is actually enough to make it work. All I've done here is say, look, instead of painting the grid directly myself, I'm going to make a grid that's pretty much empty, but I've made it, and I'm going to ask it to paint itself. And that's the identity we're talking about. This variable here is now pointing to the grid, and that variable, we go chasing the variable and ask it to paint itself. So now we can do much more with it. It's not just a nested for loop, which is a very restricted thing. A nested for loop just exists. It's now an object, which is a much less restricted thing, a much more capable thing. So because I claimed to be refactoring, let's run this to see if it still does the same thing, and it does. So that one is a win because we've given something identity that didn't have it before, and we're going to use that later on. At the moment, it feels like a pointless refactoring maybe because we haven't added anything, but there's lots we can do with grids now that we've got an identity. There's lots we can do by giving them fields and different constructors and so on and so forth. So the next thing I suggested was that these cells also get an identity. So the cell I'm talking about here is each of these boxes. And each of these boxes is represented again by this code here. This is how we paint one of the boxes. We draw a fill-in white box and then a black box over the top of it, a black outline of a box over the top of it. So we want to repeat this process of giving something an identity and then using its paint method to draw it. But in this case, there's not one cell. There's 20 by 20, 400 cells. So the grid really wants to keep track of C1. See, once we try and give them all an identity, we're in trouble. Except that we know we have a way of dealing with that in all our programming languages, which is to use an array. So notice I just made up that object again, that class again, ready to go. But I can just make an array, and because it's a 20 by 20, I'll do a two-dimensional array of these things. And it's complaining again because I haven't created that cell class, so let's go and think what that should look like. But I want to just explain that when I'm building an array of objects, I've got two of these memory allocation steps to do. Well, actually 401 of them. I've got the memory allocation step where I set aside the memory for the array, but then I've also got a step where I'm building each of those cell objects with a new cell somewhere along the way. So let's make that cell object so we're good to start using it. Okay, class cell. Oops, my computer is struggling because I left that running. Again, that's running on a tight loop, so it's going to burn the CPU. We'll get to that in a few weeks. Now, a cell, its fields would get the same trick as always, right? Fields, constructors, methods. What we could do is, with all these things when we're doing our web programming, we could sit down and think off into the future about what a cell is going to need to do, but you don't know the future because you don't know where this application is going. So we're just going to deal with what we need to know right now. Each of those cells, let's risk running the program again. Each of those cells represents one of these squares. So what's different about each one of the squares is that they're in a different location on the screen. So each cell will need to know its location. We can't just put them all in the same location. So each cell needs a field for its X and its Y. And then the constructor as always with constructors, should just build something and set those fields. Excuse me. Got my tea. Can't make videos without tea. So the constructor needs an X and a Y to know where this cell actually is on the screen. And we'll do the same trick we did before, this dot y equals y, where we're saying that the X coming in as a parameter should be set to the X that I have. Those are two separate variables, they just happen to have the same name. And the Y that's coming in on the parameter should be set to my Y, different variables with the same name. So the this, which says go back to my X and Y, not the ones that are in the local scope, is our trick for getting access to our own fields. So now we can build a cell. We can't do anything with it yet, but that's a start. So over here on grid, this will all start to work. It says, I do know there's a cell class. So you can do this. You can tell me you're going to have an array of cells, and I can build a 20 by 20 array of cells. But it's empty. There's no cells in there yet. So I need to put all the cells in there. And to do that, I'll need another one of these nested loops. Okay. So I need the exact same nested loop up here, where it goes from I equals 10 and j equals 10, because I need those X and Y positions. But now I need to put into the cell array one of these cell objects, which is like the identity for that spot on the screen. So somewhere here, I don't know exactly where yet, I put a, oops. Okay, so this is where things get a little bit awkward on this one. Oops, blip, 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 blip. What are you doing? That and that. I know that these I and j are going 10, 45, the spots I need for the X positions, and the j's are going 10, 45, the spots I need for the Y position. So I can put those in when I build the cell. But then it's a little tricky to calculate what slot in the array they should go into. But I can do a quick bit of maths to get that. In fact, it's better to do the maths the other way. It's better to say, no, let's make the i's always go from 0 to cells.length, and always make it go up by 1. And let's do the same for the j's. We'll make them go up by 1 and go from 0 to cells I dot length, which is just 20 every time because they're set to 20, but we're being defensive with our programming. So now we know that each time we build a cell, it's going into slot ij, and we do the maths on this side to say, what's the X position for that one? And the X position for slot 0 is 10, 10, 0, 0 is 10, 10, and 1, 1 is 45, 45. And so the maths to get that to work is 10 plus 35 star I and 10 plus 35 star j. So now we're passing the X and Y positions of those cells into them when they get built. So that each cell, we're creating 400 different cells here. Each cell is slightly different to the other because they've got a different X and a Y field inside them. That also means that we want to repeat this loop down here for painting them. Except instead of building a new cell each time, we don't want to do that. We just want to, when we're trying to paint the grid itself, the job of painting the grid means going to each cell and saying, hey cell, can you paint yourself? Can you paint yourself? And again, we have to send it in the graphics G for it to work on. Now this will fail for us right now because we don't have a cell paint method and we don't need the graphics there. So we better go write one. So we go over to the cells method and we fill in a paint method. So now we have a paint method. A method to think about. And it needs the graphics G to work on. Now this passing of, so the fact that the graphics has an identity has been really helpful here. If the graphics was not able to be passed around, we would have been much more constrained about where we could paint things, draw things on the screen. But because graphic is an object, we can send it off to other places and they can do the drawing. We're going to find the same benefits with grids and cells later. What does it mean to draw yourself if you're a cell? Well, the lines were in there, but I got rid of them. So let's get them back. it was these guys. And let's put those back. And so painting a cell was draw a white one, draw a black one. And now these variables don't quite line up anymore because the cell wants to draw not at ij, which were the loop variables from before. It wants to draw at xy, which are its two position variables. And we haven't imported Java AWT yet, so we better do that. Okay, so the responsibility for getting a grid on the screen is being shared around many different places now. This is much more complicated code than we had before, definitely. Before, we had a for loop in here and we were done. Now we've got a grid object, a variable grid, which has to be, an object has to be put in there, and then that object's paint method has to be called. And then when we're in the grid, it needs to build a whole array of cells, build each one of those, use a bit of funky maths to get there, then it has to separately go through and paint each of those cells. Yes, more work, and not something we would do if we didn't have future things in mind, but we can at least see that it's doing the same job. All of these are a benefit for the future, but what we want you to get your head around is that this is the object-oriented modeling view of how we would put together the program. We take each of the things that exist in the program, we give them an identity as an object. So in this case, each of the squares on the screen were given an identity as an object. And then the whole grid itself was given an identity as an object. And then we built the program around the idea that that was important. So good OO design is about picking the right things to have an identity and designing the program so that it's a neat implementation of that identity, those identities. And here we've decided, now this application has one main object, one app object, one grid object, and 400 cell objects. Okay. So what's a good OO design and what's a bad OO design is something that we'll get to eventually. But an OO design is one where things have been given this identity so that they can exist as an object. Once they're an object, they're what we call a first-class citizen of the language, meaning we can pass them around and we can modify them. And that's the power. Lifting the concepts from your program up to that level so that they have extra capabilities is a really important part of modeling power that gives us some kind of hook into the complexity that always comes with programming. Okay. So I'll just stop there and then I'll get going on, then I'll make up another video for talking about the mouse stuff. Bye for now.